We're going to take a look at applications of cosine law now. Okay, so we'll do a couple word problems and a couple where we have to draw it. So find the measure to the nearest degree of the smallest angle, so we want theta, in a triangle with sides 4, 7, and 9. So when we draw this triangle, we can just draw it as a acute triangle. We'll call this A, B, and C. Okay, doesn't matter. So we want to solve for the smallest angle. So if we label the sides 4, 7, and 9, the angle that we would want to actually solve for is C, because the smallest angle is going to be opposite the smallest side. So let's set up our ratio with the C on the outside. Okay, C squared equals A squared plus B squared minus 2AB cos C. Now we sub everything in. 4 squared equals 7 squared plus 9 squared minus 279 cos C. And we're solving for C, so it makes sense that we are not subbing anything in for C. Okay, now we can move everything over. We'll get 4 squared minus 7 squared minus 9 squared divided by negative 279. Okay, and that's going to equal cos C. So when we expand that, 4 squared minus 7 squared minus 9 squared is going to be, in the numerator, negative 114. In the denominator, 2 times 7 times 9, I get negative 126. Okay, so we want to cos inverse this. Cos inverse 114 divided by 126 of 0 decimal 9047.6, and this is going to equal angle C. So angle C equals 25 degrees. Okay, so angle C, we'll put angle C equals 25 degrees. So that is the smallest angle in that triangle. Example 2. The diagram represents a radar station at point A, which is over here. It's tracking the ships at B and C. Okay, so there's an observer on ship B. So there's a person right here on ship B. The ship has a sailboat. Okay, calculate the angle between the lines of sight to the ship at C and the radar station. So this guy is looking between A and C, right? So we want this angle right here. Okay, what are we given though? We're given side C, which is 4.2. We're given an angle, the contained angle, and side B, which is 6.3. So to be honest, we don't have a matchup. We can't use sine law, and we don't have any information about this B. Like we don't have side A. B would be the contained angle between C and A. So we actually have to find side A first. So this is going to be a two-step problem. Okay. So let's go with cosine law. We're going to find side A. So it's going to be A squared plus B squared plus C squared minus 2BC cos A. Okay, so it's going to be, B is 6.3. So it's going to be 6.3 squared plus 4.2 squared minus 2, 6.3, 4.2 cos, and then the angle that we have for angle A is 82. Okay, remember, this entire thing should be able to go into your calculator. Minus 2, 6.3, 4.2, cos 82. I get 49.96. Now, when we root both sides, I get 7.1. Okay, and that's going to be in kilometers. So, going back to purple, A is 7.1 kilometers. Now we can use cosine law because now we have CA and the contained angle, which is B, and we can solve for side B. So this one's actually quite easy because, again, we're solving for side, which I find the easiest. It's so straightforward. Okay. And this time we're solving for B. So B squared equals, oh, I'm lying. We're solving for an angle. It's not that easy, but it's still easy. Okay. B squared. (6.3) squared equals A squared, which is 7.1 squared, plus C squared, which is 4.2 squared, minus 2, 7.1, 4.2, cos, and then angle B we don't know. Okay, if we bring over the 7.1 squared and the 4.2 squared, we're going to get 6.3 squared minus 7.1 squared minus 4.2 squared all over negative 2, 7.1, 4.2, and that's going to equal cos B. Okay, so 6.3 squared minus 7.1 squared minus 4.2 squared. I get negative 28.36. Okay, and then in the denominator, I get negative 59.64. And when I divide those, I get 0.4755. Okay, so I get B equals cos inverse of 0.4755. And when we cos inverse this, we get the angle B. Angle B equals 60, let's go 62 degrees. Okay, so your therefore statement should say the angle between the lines of sight between the radar station and ship 2 is 62 degrees. Okay, example 3. 2 points B and C, so we see B here and we see C here, are located at each end of a small lake. And then point A is on land. Okay, so this is looking from a distance away. Okay, the distance from A to B and A to C and the measure, like the contained angle here, are shown. So we have A to B is 300 meters, A to C is 400 meters, and the contained angle is 47 degrees. So we need to find the length of the lake BC. So we want to find this to the nearest meter. Okay, so this is beautiful because we have A and we're trying to find side A. So we can simply go A squared equals B squared plus C squared minus 2BC cos A. And now we can just sub in. Okay, so we have, side B is 400 to be absolutely accurate. 400 squared plus 300 squared minus 2 400, 300 cos of 47. And all of this can go into my calculator. 400 squared plus 300 squared minus 2 400, 300 cos 47. I get a really big number. I get 86,320. And then there's like some decimals, 394. 394. Okay, when we root this, we root both sides and we get A equals 293. Decimal 8, we want it to the nearest meter. Let's go A equals 294 meters. So our therefore statement, it'll fit this time. I didn't write it last time because it wouldn't fit, but I said it out loud. So therefore for the length of the lake is 294 meters. And that's it for that question. Okay, example 4, last example. A golfer hits a tee shot, so the ball's on the tee, on a 350-meter long straight golf hole. So the golf hole is long and straight. That's like the entire green. It's not the green, but like the length of that one hole, like maybe hole number 1. Okay. Now the ball is sliced. So what slice means is hit at an angle of 21 degrees to the right. Okay, so it's sliced 21 degrees to the right, and the ball lands 210 meters away from the tee. So we can see the ball here. How far is the ball from the hole to the nearest meter? We're looking, let's go A, B, and C. We're looking for side A. We want to know, like the guy hits it, it goes off course, it doesn't go straight on. Okay, so we want to know how far the ball is from the tee. So all we need to do is solve for A, which is quite easy, because this is what we've seen so far. A squared equals B squared plus C squared minus 2BC cos A. And all we're going to do is sub in B, which is 350, square that, plus 210, square that, minus 350, 210. I'm just continuing underneath. Cos 21 degrees. Okay, we put this entire thing into our calculators. So 350 squared plus 210 squared minus 2 times 350 times 210 cos 21. I get 29,363 decimal 68. And now I want to root that. And just remember, I rounded on the board, but in my calculator, I just leave it. So now we have A squared. Sorry, just A, because we're rooting it already, is 171 meters. Okay, so then we can say, therefore, move this down, put it in black. Okay, therefore, the ball is 171 meters from the TEE, the TEA. All right, and that's it.